Hello everyone, welcome to you in my YouTube channel. And today we are going to learn a very interesting lesson, number systems. You just concentrate on this. The name of the chapter, that is number systems, means there are many systems of numbers. So here I wrote here, the first one is decimal system. The base of decimal system is 10. Base means in decimal system we are using 10 numbers, 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The total 10 numbers we are using. And in our real life we are using decimal system, and we are making any number we can make with the help of 0 to 9. So that's why this base is 10, because 10 numbers we are using. The second system is binary system. In binary system, we use only two digits, that is 0 and 1. That's why it is called binary system. And the base of binary system is 2, and mostly we are using this system in computer system. This computer is using this one, because in computer, if electron is flowing, then computer is taking 1. If electron is not flowing, then computer is taking 0. Similarly, octal system, here we are base is 8. We are using numbers from 0 to 7. In hexadecimal system, here base is 16. So 0 to 9, this is 10, and from A to F, that is 6. So total base is 16. So this is about the number system, because the name of chapter is number systems. That's why I am telling you what is number systems. So in our life, we are using decimal system. So I'm starting from here. In decimal system, numbers are two types. One is the real number, which we are using in our life, and the second one is imaginary number, which we are not using in ninth grade. Just I'm classifying this one, but you will learn about imaginary number in another classes. So in what is real number? Real numbers, those numbers can be represented on the number line, is called real number, and imaginary number cannot be represented on the number line. Now, classification of real numbers. So real numbers, they are two types: rational numbers, and the next one is irrational numbers. This can be written in the form of P over Q, where P and Q are integers and Q is not equal to 0. So rational number can be written in the form of P by Q, where P and Q are integers and Q should not be equal to 0, because it is a denominator. It cannot be written in the form of P by Q. So now, if you think about the numbers which can be written in the form of P by Q, that is this one. So like all integers we can write in the form of P by Q, all integers. For example, if I write 3, can be written as 3 by 1. If I will write 0, it is 0 by 1. If I will write minus 4, this is minus 4 by 1. So now we can say all integers are rational numbers. All integers can be written in the form of p by q. That's why all integers are rational numbers. Now, other than integers, now we will think about the decimal. So decimals are three types. Decimals. They are, first one is terminating decimal. Second one is non-terminating and recurring or repeating. And the third one is non-terminating and non-repeating decimals. So three types of decimals we have. So what is terminating decimal? How to know that is a terminating decimal? So I'm taking one example. Suppose 3 by 2. If you divide 3 by 2 one time, then 1. Now after that there is no digits, so keep here decimal and you can copy 1 0. 2 5s are 10. When we divided, it is remainder is 0. So whenever you divide a number by another number and remainder is coming 0, then that decimal is terminating decimal. It is 1.5. So terminating non-terminating decimal, for example, if you divide 2 by 3, so divide it 0 time, because it is less than divisor, so 0 time, then there is no digit, so decimal, then 1 0 you can copy, 3 6 are 18, then again 1 0, you in every step you can write 1 0. Now 3 6 are 18. See, again and again we are getting the same remainder. It means it is non-terminating but repeating, because same remainder you are getting. Here continuously you are getting same remainder. In some cases, after three step division you will get same interval. Then after every three step you will get the same remainder. Or after four steps of division you will get the same remainder. Maybe after 10 steps of division you will get the same remainder. For example, 10 step you divided, you got remainder 3. Then again divide 10 steps, you will get remainder 3. Then again divide 10 steps, you will get remainder 3. So in that case also, non-terminating and repeating decimal, because the remainder is repeating. So such decimals are known as non-terminating. See, here 6 is repeating. So maybe one digit is repeating, maybe two digits repeating, maybe five digits repeating, depends on numbers. So this we are writing by using bar sign. Here infinitely many 6 are here. So just we are putting bar sign here. It means this digit is repeating. Here non-terminating and non-repeating decimal. So all fractions may be terminating decimal, may be non-terminating and repeating decimal. All fractions. Only radicals means square root 2, square root 4 is a terminating decimal. See, square root 2, square root 3, square root 5. These are the examples of non-terminating and non-repeating decimals. These are the examples. Because if I will say square root 4, it is equal to 2, it is integer. So integer means it is 2.0. So it is a terminating decimal, square root 4, square root 9, and so on. So they will represent the values of square root 2, square root 3, square root 5. And how to know it? If square root 9 is given, the value of square root 9 is exactly equal to 3, that is an integer. So now we can say square root of a number which is not equal to any integer must be non-terminating and non-repeating decimal. So these two decimals are known as rational numbers, and this is called irrational number. This one is some more example in decimal form. How we can write the example for this non-terminating we and non-repeating 0, then 2 zeros, then 3 zeros. It means zeros are increasing. So this is a pattern. In this pattern we are writing, we are showing it is non-terminating, non-repeating. So this is a pattern. You can write here 3, then 0, then increasing 1 1 zeros, or you can increase any digit like that, 0.5 1 5 1 1 5 1 1 1 5, and so on. Here 1 is increasing. This is called irrational numbers. So rational number and irrational numbers. With the help of decimal, we classified decimals into three parts, that is terminating decimal, non-terminating and repeating decimal, non-terminating and non-repeating decimal. Terminating and non-terminating repeating, it is rational number, and non-terminating non-repeating decimals are irrational numbers. So this is about the concept, and now we will do exercise 1.1. In exercise 1.1, first question is 0 a rational number? So 0 is integer, and all integers are rational number. So answer is yes. And then it is written, write the reason also. So you just reason is 0 equal to 0 by 1. It is in the form of p by q, and q is not equal to 0. Second question, write 5 rational numbers between 3 and 4. So 3 and 4. All fractions are rational numbers. All terminating decimals are rational numbers. All non-terminating repeating decimals are rational numbers. So between them, if you want to write the rational number, we can write in two form. The first one is decimal form, and second one is fractional form. Decimal form is very easy. You write a number greater than this, less than this. So it is 3.1, 3.2, 3.3, 3.4, 3.5, etc. Now, fractional form, how to write? It is 3 and it is 4. So write in fraction form 3 by 1, 4 by 1. They have same denominator. Whenever you want to write the numbers between fractions, they must have same denominator, or you make denominator same denominator. So now denominators are same. Then you see the numerator here 3 and here 4. Between 3 and 4 there is no number. There is no any integer. We are just checking integer. So change this denominator. So I am multiplying by 5. So 15 by 5 I got, and this also denominator we will make it equal to 5. So I am multiplying by 5. It is not necessary to multiply by 5. You can multiply by any number. It's your choice. So it is 4 by 5. Now see between this and this, it is 5 4 the 20. You write the number 16 by 5, 17 by 5, 18 by 5, 19 by 5. 1, 2, 3, 4 numbers we got. We got exactly 4 numbers. If you need more numbers, then you again change this denominator. Suppose if you multiply by 2, then here 30 by 10, here 40 by 10. Then in this case, you can write 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10, 36 by 10, 37 by 10, 38 by 10, 39 by 10. Here I got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers I got. So if you need numbers between any two numbers, you can get many numbers. But here we are getting only 4, 1, 2, 3, 4. And suppose you need 6, then like that you can increase denominator and you will get more numbers. Now next question. 5, write, it is an extra question. Write 5 rational numbers between 3 by 5 and 2 by 7. If you want to write in decimal form, so you divide it, get their decimal values, and you can write the number. But whenever fractions are there, we prefer fraction. So now what we do, 3 by 5 and 2 by 7. They have different denominator. Whenever numbers are having different denominators, first you find the LCM of their denominators. So LCM of 5 and 7 equal to 35. This is the LCM. So make each denominator equal to LCM. Here denominator is 5, LCM is 35. So 5, 7 the 35. So you have to multiply it by 7. So 21 by 35. Here denominator is 7 and LCM is 35. So here you have to multiply by 5 because 7 5 the 35. So 10 by 35. So what we did, because they have different denominators, so we got the LCM of denominator and then we made each denominator equal to LCM. And now check it. You are getting numbers or not? How many numbers required? 5. It is 10, it is 21. So 11 by 25 we are going to get. So numbers are 11 by 35, 12 by 35, 13 by 35, 14 by 35, 15 by 35, 1, 2, 3, 4, 5. So this is a way to find the rational numbers between two given rational numbers with different denominators. And textbook, in every question denominators are same.